Howdy everyone, we're back again, chapter 1, analyzing categorical data. So we're going to now look at two-way tables, so looking at tabular data, and we're going to talk about two ways to look at and collect that information and to distinguish between what is known as a marginal distribution and conditional distributions, and how to then be able to make some sort of analyses and associations between the two things that we're measuring. So let's look at the board and look at the example that's here. So I copied this one straight from the textbook as one of the example tables that they gave you. So I want to just kind of run with this and use this to help explain the difference between the two. So some information was collected from some young adults, and it was an opinion based on their chances of getting rich. So we have recorded here by gender and then by opinion. So in reading that first row, we would say, okay, well, 96 females have the opinion that they have almost no chance of getting rich. This 720 here would mean that the 720 males had the opinion that they had a 50-50 chance of getting rich. So we would normally have these numbers, and then these totals here off to the side are just totaling up the genders and then totaling up the opinions. So in total, we spoke to 4,826 people, both males and females. Okay, so that would be my total there. So first, let's talk about what is a marginal distribution. So a marginal distribution, as the name implies, margin is these numbers here, both on the right-hand side and on the bottom. So a marginal distribution, when we're referring to, so like the marginal distribution for females would be this number right here, this 2367. The marginal distribution for no chance would be this number here, this 194. So marginal distributions look at a specific variable. Okay, it's looking at a specific, so you can think of this again. So margin said, and it's looking at single variable. Okay, so understand there's two variables here in this table. There's gender and then there's opinion. Now, when we look at a conditional distribution, then we're looking is at two things happening at once. So a conditional distribution, we could start by using the condition of gender. So as an example, let me erase these numbers here. I might decide, well, how many, let's look at what is the conditional distribution of females, the conditional distribution of having no chance based on gender. So if I'm going to base it on gender, so distribution of no chance based on gender. So now gender becomes, okay, that's my denominator. So I could see that for the females, there's 2367. So for females, it would be 2367. So we're looking at what's the distribution of no chance. So now I would grab, 96 out of the 2,367 are giving that. Now for the males, it's a different number. For the males, 2,459 males, out of them 98. So these will come out to be obviously percentages. So then we can use conditional distributions to help us determine if there maybe is some association between these two variables, because we're looking at two things at once. In a marginal distribution, you are not. You're looking at a single variable. We can't make an association just on a single variable. We need to look at two variables. So conditional distributions allow us to do that. So if I were to work these out as actual numbers, so pull out my trusty calculator here and we'll actually work these out. So 96 out of 2367. So that gives me we have a less than 4%. See? Yeah, so less than a 4%. So 4, 6. Now if I do 98 over 9, I get is about 3%, 0.0399. Okay, so we see that there's a slight difference. So if I looked here and I only looked at this number, I only looked at this one opinion, it seems to me that based on the gender, there is a slight difference. It seems more females have the opinion, so it looks like gender is making a difference. Now, just based on this one opinion, we really shouldn't make that conclusion for that association. I would then do the same thing for each of the other 4 opinions to then kind of make a determination. Maybe there is an association. Gender does influence the opinion. We could also look at a different condition. I can look at the condition of the opinion. Based on opinion, does that influence the gender of the person? So I could go the other way and I could say, okay, the distribution of gender based on opinion. So if we were to take that same row, that first opinion of almost no chance, now I'm going to be looking as horizontally. This would become my total. So for female, I see what? Oh, 96 females out of the 194 versus 98 out of the 194. And I'm going to work these numbers out so you can see it's not going to be the same numbers as these. So 96 out of 194. So we get, this is about 0.495. And then we got 98 over 194. And then this is going to be my 0.505. So you can see these are now totally different numbers than what we had over here. So when we're thinking about trying to see if there's an association between the 2 variables, we have various ways to kind of analyze the table. So there isn't a right or wrong, but there is one that would probably be more useful to us. So in my case here, if I wanted to ascribe, is there a relationship between gender and opinion? I would probably look at this way of doing a conditional distribution versus this way here. Because if I just look at the opinion, so if I go down this route, so if I just look at the opinion only and see, does that determine the gender? That's really not what I'm trying to, that's not really the question I'm trying to answer. What I'm trying to answer is, does gender influence opinion? If I look at it this way, this is saying what? The distribution of gender based on opinion. So it's kind of like, give me your opinion. Now I'm going to see this. Did that determine your gender? No, your gender happens first. So that should be what we are basing it on. So when we're asked to do conditional distributions, this is the part we kind of have to think about of like, it's not just a simple divide 2 things and that'll be it. Which way is going to be the way that kind of falls in line with the question we are trying to answer?